manufacturing, and where we have to bother about the quality of this steel, reinforcement steel, about 44%. So why we talk about quality? As I mentioned earlier, quality is not just necessary for reinforcement steel, but it is also necessary for the other products. Since our industry is not controlled, many of the products are manufactured without any quality control in place. Anybody who has got some finance, they can start an product manufacturing in our industry. And there are no strict guidelines or eligibility criteria for giving licenses to the product manufacturers. So with this background, as users, as civil engineers, we have to be very careful about the quality, and we should identify and select the manufacturer, supplier of products based on their background and the quality consciousness of the people. Once we start recognizing the quality conscious manufacturers and suppliers, then automatically the industry will transform from unorganized sector to organized sector, where quality will be one of the most criteria in their aspect. As I mentioned earlier, the concrete products, we have been doing a lot of activities and programs, seminars, workshops, and other things to sensitize people about the quality of concrete. Now we should talk about more and more on reinforcement steel also in the days to come. So we have various issues in the civil engineering industry, whether it is storage of material, whether it is fabrication, various aspects. It may not be so bad as of now. Some time back, I've taken these photos from the open source. But today, the industry may not be so bad as this, but we still find the storage of material not much difference as shown it is here, because we don't give much importance for storage of reinforcement at these sites. So many of our sites will look like this even today. So there are a lot of issues like this. It is not just from the manufacturer, from the selection of the raw material to the manufacturer, then delivery to the site, and handling the material in the site, and then using as reinforcement in the reinforced concrete, and quality issues at various stages, and proper measures at various stages are very, very important. So you can also see some of these sites in the scenes in the sites where the corrosion and other aspects are not taken care, and demolished steel is also reused without processing. That is also another issue. And fabrication also, a lot of issues are there. We should know how to detail the reinforcement. So detailing of reinforcement is another major area. All of us involved in the analysis, design, and implementation should take care. And we can have one more webinar on detailing of reinforcement also. And proper concreting methods also very, very important. So these things are there. So look, when you look at these issues, we have construction quality as a whole as a major concern. Even though many of the high-tech consulting firms are there, and multinationals are into the industry, and major projects, maybe construction quality is taken care but the medium and small industry projects, we still find some of these issues are there. And definitely we should find solutions to all this, and address from manufacturing process, and we should see whether the proper infrastructure is there to manufacture from a particular manufacturer, and selection of the manufacturer and supplier based on the quality systems that they have implemented, because that is the place basic properties of the material are concerned. Unless they have a proper infrastructure and manufacturing process in place, will not get good product. So then understanding the properties and behavior of the material as a reinforcement behavior, we need to understand. Then once we understand the properties and behavior, we become more sensitive to select a good product. So how to store and use the reinforcement, again, there are a lot of aspects up there which makes a lot of difference while in the overall strength of the building. And testing of reinforcement and quality checks at each level starting from the raw materials to the manufacture till we use the reinforcement. We need to adapt the proper testing reinforcement methods and quality checks in place. So we have different types of reinforcement bars. You have deformed bars, you have stainless steel bars, you have epoxy coated reinforcement bars, then galvanized rebars, FRP bars are very popular these days. A lot of is talked about, and the equipment used for the reinforcement fabrication and other things. Rebar tying machines are available. We should use all these latest methods to minimize the loss and the efficiency of the use. We are having a lot of couplers in place. We can save material if you use proper couplers. We have different tests for the reinforcement. The bar bending machines are available these days. So there are a lot of solutions available based on each of the problem to address each of these problems that we are facing in the industry. There are a lot of solutions are also developed by various manufacturers. We should be aware of what is available in the industry, and based on the knowledge, we should select the best material, best product, best equipment to use the reinforcement. And bar bending is a major aspect in the reinforcement steel. Many a times we use bar benders who are not skilled, properly trained bar benders. So we end up with a lot of problems as far as bar bending is concerned. So the automatic rebar bending systems are also there in place as far as the bar bending issues are concerned. Now many people are coming into the industry who, if you give the reinforcement drawing, the execution drawing, they will supply the ready-made steel. You can just bring it and place on the plain place, and then you can start concreting. So this is also getting more and more visible in the industry. And the accessories used in the use of reinforcement, you have whether it is cover blocks and other chairs. Normally, we call it as chairs for taking care of these aspects. So each one of this is a major area where the user should be aware of the different products available and other things. Formwork is also another major thing responsible for quality of the structure and the use of reinforcement. So uh, from M15 concrete, now we are talking about M200. So we have already demonstrated M200 concrete in one of our concrete webinar and the Indian Concrete Institute. But widely, people are using now M60 and M80 grade concretes. M120 is also used in some of the projects. So as we use higher grade concretes, we reduce the material usage. Similarly, in steel, we are using 415 steel, Fe 415 steel. Now we are talking about Fe 600 grade steel. So it is always better to select a good manufacturer and use higher grade steels. For a lot of benefits are there if you use high grade steels. So we should promote more and more usage of high grade steels for reducing the material usage. So for all this, which is our Bible, the IS 1786 2008, it is amended in 2012. So this is our major thing. When we talk about concrete, we have IS 456. When we talk about structural steel, we have IS 800. And when we talk about reinforcing bars, so this is our uh, Bible, IS 1786, high strength deformed bars and wides for concrete reinforcement specification. So I strongly recommend all the users who use reinforcement steel should read IS 1786 completely and understand each word printed in this code. It is very, very important. Now, in the industry, we are having all these materials, Fe415, Fe415D, Fe415S, 500, 500D, 500S, 550, 550D, and Fe 600. Now, 415, very minimal use is there, and that is not available unless you demand. from the manufacturers, and majority of the manufacturers are producing Fe 500 and Fe 550. If you ask for, if they will also supply Fe 600. So these are the major grades. I have taken an extract from IS 1786, and these are very, very important. So let us focus more on these high grade steels which are presently used in the industry, especially in the form of TMT, thermomechanically treated bars. So when it comes to the composition of the steel, normally we don't care, or we don't give a lot of importance for the chemical analysis of the steel material. Normally, as site engineers or project engineers, we check for tensile strength of the reinforcement. And when it comes to concrete, we do the cube test for checking the compressive strength of the material. When it comes to steel, we check the tensile strength. But compression and tension, compressive strength and tensile strength is not the only two strengths that are responsible for the overall safety and longevity of the structure, the durability of the structure. There are many other issues which are also responsible for long-term efficiency of the building. So when we talk about reinforcement steel, as per IS 1786 amendment, these are the major ingredients which make a lot of uh, uh, responsible for the properties of the steel. So the carbon content, sulfur content, phosphorus content, and sulfurous and phosphorus, the combination of this should not be should be as per this code 1786. So when we talk about Fe 500, the carbon content is maximum up to 0.3%. Initially, I was telling the maximum usage should be about 2%, less than 2% in various other types of steel. But as far as reinforcement steel is concerned, the carbon content should be less than 0.3%. Sulfur should be less than 0.005%. Phosphorus 0.055, and sulfur and phosphorus together should be less than 0.105% for this particular grade of steel. For other grades of steel, it is mentioned here. So this is responsible mainly for the properties of the steel. And the nominal sizes of bars wise are available in the market. We have from 4 mm to 50 mm. So 10, 8 mm, 10 mm, 12, 16, 20, 25 are widely used. And the higher diameters of 28, 32, 36, 40, 45 to 50 mm, these are not widely used, but available in the market. So the mechanical properties of high strength deformed bars and vice is also based on this. The various parameters, properties are given here. The 0.5, 2% proof stress, TS by YS ratio, elongation, and total elongation are very, very important properties as far as the reinforcement is concerned. And when you test, it should specify according to this for different grades of steel. So this table should be remembered by all the civil engineers when we are using reinforcement steel, and it is very, very important. And many of the manufacturers don't give a lot of thrust in maintaining this elongation ratios. Say, for example, for Fe415D, it should be about 18%, 18, and for Fe 500, it should be about 12. So this is also very, very important. Elongation and total elongation also is given. And the ratios of TS by YS also should be properly maintained. So when you test the material, these aspects should be taken care. And the composition of the various chemicals, the chemical analysis, if you do, normally you have a lot of instruments to check the chemical composition of reinforcement bar. Spectrometers are available, which gives you about up to 27 elements, 27 elements which are present in the steel reinforcement. So based on that analysis, if you look at the contents, and if you identify these materials, based on the percentage of the materials present, the properties of the mechanical properties of the material will also change. Say, for example, carbon. Higher carbon contributes to the tensile strength. So that means more percentage of carbon, you get more tensile strength, but it should be very careful. higher load bearing capacity and vice versa. Lower carbon content less than 0.1% will reduce the strength. Higher carbon content of 0.3% and above makes the steel bar unweldable and brittle. So you cannot increase the carbon content just because you get good tensile strength, because if it is more than 0.3%, then the material becomes unweldable and it becomes brittle. So therefore, you have to be very careful about using the carbon content. And we are also very particular about sulfur and phosphor. More content of sulfur and phosphor is very bad for the reinforcement. Say, for example, presence of sulfur should be limited as per IS 1786. Presence of higher sulfur makes the bar brittle during twisting, as higher sulfur content brings the hot shot problem during the rolling. So when you do the bending and rebending test, if you have more sulfur and phosphorus, it becomes very difficult for bending operations or fabrication operations. Higher phosphorus content contributes to the increase in strength and corrosion resistance properties, but brings brittleness due to the formation of low phospholicals in the grain boundary. Also lowers the impact value at sub-zero temperature level, transition temperature. So chemical analysis in addition to tensile strengths is also very, very important for reinforcement steel. So when you look at IS 1786 again, it is very clearly given the tensile test. The tensile strength, percentage elongation, percentage total elongation at maximum force, and 0.2% proof stress of bars wise shall be determined in accordance with the requirements of IS 1608. So, it should also be done as per IS 2062. So, the tensile strength, the method of testing is also very, very important, and you have to be very careful while conducting the tests. Many of us, we just do a tensile strength without bothering about the procedure and the method of doing the test. So, that is also very, very important. So, you follow the guidelines given in IS 1786 for doing the strength tests and quality tests for reinforcement. The other two important tests are bend and rebend tests. So these are also very, very important, especially about the rebend test. There are a lot of misconceptions in the industry, the way of doing the rebend test. So it is very clearly given here. The test piece shall be bent into an included angle of 135 degree using a mandrel of appropriate diameter. So this is very, very important. People, when they use rebend test, they don't use proper mandrels and the diameters. So that is very, very important. If you take care of this and do the rebend test, then we can assess the quality of the bar very effectively. The bent piece shall be aged by keeping boiling water for 30 minutes and then allowed to cool. The piece shall then be bent back to have an included angle of 157 degree. So I will not get into the procedural aspects of testing. So this clear indications are given and procedure is given in IS 1786 and other relevant codes. Use that, and or you use the facilities available in one of the accredited laboratories as per NABL. Then you get a good quality test and properties of the material. So the mandrel diameters, as I said, for rebend tests given again in the code. So this should be used for effective testing methods. So some sample specifications for reinforcement. So I've talked more about IS 1786 and should not be boring for all of you. So as I said, the main codes IS 432, IS 1786, IS 2062. These three codes are mainly important for mild steel, high strength steel, and structural steel. So read these guidelines given by BIS, and I'm very happy to state at this point of time, the Bureau of Indian Standards, BIS, is very efficient and active these days. The BIS Civil Engineering Division is headed by Mr. Sanjay Pant, and he is taking a lot of effort in revising all the codes. Earlier, to get a code revised, we used to wait for 10-15 years. Now, every year, a lot of codes are revised as per the requirement of the construction industry and civil engineering industry requirements. And you can visit BIS website You can also contribute to the development of the codes. You can send your comments for the revision. So a lot of opportunities available for civil engineers to get into the codal formation and codal preparations. So you can visit BIS website for more details. So as I mentioned earlier, there are a lot of accessories like spacer blocks and power blocks, chairs and other accessories. So we should know how to use them very effectively. And cutting and bending is another major aspect. Again, for that, we have a code and we should use the code effectively. Storage of reinforcement bars and steel fabric. So that is also, I said, we have to use the proper methods and checks to take care of the reinforcement at the site. Fixing reinforcement is the major job. That is the detailing of reinforcement. This should be done as per the structural engineers' recommendations and the detailing code of IS we should follow. So now come back to where the quality is affected, the bar quality is affected. Checking, testing, usage of reinforcement and all those things is the responsibility of the structural consultant and project engineer. But if the material itself is not good, then we can't do anything. Whatever we adopt, the methods adopt to take care of the quality, it is waste. So influencing factor is the quality of reinforcement is the manufacturing process, steel making process. So we should give a lot of importance for the manufacturer while selecting the reinforcement. So this we need to stress. And the characteristics of steel reinforcement also the very important for the strength and ductility and the corrosion. These aspects also we should take care. So IS 1786, as I said, it is very important. There are different types of twisting of bars. I will not get into it. So this slide, I will spend some time. Now, most of the steel we are using in the construction industry as reinforcement steel rebars is TMT bars, thermomechanically treated bars. And that is introduced in India during 1980 and 85. At this stage. So thermomechanical treatment is an advanced heat treatment process in which hot bars coming out of a last rolling mill stand are rapidly quenched through a series of water jets. So 1700 degrees Celsius, the molten material, it will comes into billets and then billets will be rolled into the reinforcement bars. And in this process, the hot bar should be cooled to normal temperature. And this process of cooling, quenching is very important. So if you take care of this process very effectively, then we get a good quality TMT bars. Rapid quenching provides intensive cooling of surface, resulting in the bar having ardent surface with hot core. The rebars are then allowed to cool in ambient conditions. During the course of such slow cooling, the heat released from core tempers the ardent surface, while core is turned into ferrite perlite aggregate composition. So this is the actual sample I have taken from a factory. After this proper quenching system, you get a rings like this. This in general terms, the in the field people use as a ring test for this. So you have to conduct a ring test on a reinforcement bar. If you get three rings like this, the core, then the transition layer, and then outer hardened surface. So if you get three rings like this, then it is a good quality TMT bar properly manufactured. So TMT process thus changes the structure of a material to a composite structure of ductile ferrite perlite composition with tough surface rim of tempered martensite, providing an optimum combination of high strength, ductility, bendability, and other desirable properties. TMT bars of grade 415, 500, 550 are now available in India, up to 600 also available in India. So this is the process of TMT bar. It is a heat treatment while manufacturing the steel. So you can identify the bar. This is one common test everybody can do at site for identifying whether it is a good quality TMT bar or not. So identify quenched and tempered TMT bar. Project site engineers and all civil engineers should be able to distinguish and identify good quality bars. So Ensure the mill that has supplied the rebars has a genuine quenching tempering technology. Check whether the Q&T technology supplied to the mill is by an authorized and competent organization. Check the license. All these things we don't do, but if you identify a good manufacturer, they will take care of all these things. So what is the field test? So field test the rebars at random. The first thing to be done is filing the surface of the rebar with the help of workers, rough and file. A site worker will easily recognize if the surface is hard or soft. All Q&T bars have the harder surface than unquenched bars. Finally, random sample should be drawn. You take a sample reinforcement bar from the lot, and you finish the surface with emery paper and small file, and then the cross section is smoothened to a fine polished state by grinder and emery paper. The smooth end of the sample is then pickled in nitrile solution, 5 to 10% nitric acid with a balanced ethyl alcohol. The result should show a uniform tempered martensite periphery with a softer core close to good TNT bar. So when you press this reinforcement bar finished surface into the nitrile solution, you should get a surface like this. So you should get identify by naked eye the three rings of the bar. So if you get that, then you can say it is a good quality TMT bar. So in the absence of other more refined tests, this can be done by any engineer with a simple test of nitrile solution, dipping into the nitrile solution at the site. So as I said, the process of manufacturing is very, very important. I'll run through, I think we have time. I can run through the process. So if necessary, if you're using the reinforcement continuously for your projects, it is absolutely necessary for you to make a visit to the manufacturing plant. Like we visit RMC plant before ordering the concrete. We will send our project engineer or quality engineer to the RMC plant. How the plant is managed, whether the skilled workforce is there in the plant or not. Everything depends on however automated industry we are talking about. Unless we have a trained, skilled manpower at the plant, it is very difficult to manage the process. So you need to have a trained, skilled manpower for RMC production. Similarly, you need to have a trained engineers or the metallurgist in specific to steel industry at the plant who can process the manufacturing for the steel as per the requirements of the IS codes. So visit the plant and get convinced yourself about the manufacturing process, the quality checks that they are following. So if the manufacturing process is good, then automatically we get a good quality reinforcement steel. So I insist all the users to get convinced about the quality of the manufacturing process before you order your reinforcement steel. As such, we don't have any certifying systems for reinforcement steel industry. We have QCI certification for RMC plants. Similarly, we need to evolve in the days to come some kind of certifying process for the reinforcement industry also, steel manufacturing industry also. So normally they will have a continuous billet caster if they have a good infrastructure for manufacturing the steel. Then you have fully automatic controlled hot rolling systems will be there in the industry for a good infrastructure for the manufacturing. And they have, as I said, the TMT bar process is cooling the high temperature to the ambient temperature. It depends on the QST system. So they should have a proper system, proper controlled system of temperature control. You can see a display here, the temperature controlled at various stages of the reinforcement. So based on that, from 1700 degrees to the required temperature cooling, you need to have a proper cooling system. Then automatic cooling bed you should have once the bar is cut into different sizes. And during the raw material stage, as I said earlier, I mentioned there were many of the good manufacturers, they use a spectrometer for chemical analysis of the raw material. Once they use raw material and before moving forward for the manufacturer of steel, they should check the samples. I have taken this from one of the manufacturers' testing facility. The spectrometer will give about 27 chemical elements, the composition of chemical elements, and you get a result like this, the computer generated tabular form, and you have to see the composition of the various materials here. Compare with your IS 1786, what is the maximum allowed percentage of the materials of various chemicals, and remodel the mix. In other words, the composition of the raw material. If something is less than required, then you have to add, and if it is more, you have to eliminate. So that process you have to do before allowing continuing with the manufacturing process. So the spectrometer analysis is very, very important, and it determines the durability of the material also. And you get a sample test like this. This is a report generated by the spectrometer. The dates and timing is also mentioned. So that will also give an indication for every batch of manufacturing of the billet. You do this test very systematically. So you get the combination of all the 27 elements here. So that is one of the very, very important facility any manufacturer should have at their manufacturing plant. And after manufacturing, you have to test the bars as per the sampling requirements in the factory itself, and see whether you get a good performance of the material as per the standard requirement at the site itself. So this is sample collection and testing at the site during the charging process. These images are just showing you for the purpose of understanding what is the manufacturing process, how important it is, and other things. So this is the quenching of bars, how the hot bar which gets into the quenching system comes out after cooling. Outlet bar temperature control panel. Almost all good manufacturers will have automated computerized QST system these days. And it will ensure good quality manufacturing, will also ensure the grade. The allowance is about plus or minus 20 kilonewton. And you will have automatic bending and cutting machines at the place. So the next few minutes, Rahul, I think I have some more time. Okay. The defects in rolled steel inspection on testing. Some checklists I have given here at the end to conclude before concluding. I think very, very important for all of you to take care of this. In order to produce satisfactory rebar products, it is important that an adequate quality control system be established and maintained. This system should include mechanical and metallurgical testing as required, and the inspection of the surface and other defects. Metallurgical testing. So its complete process is a metallurgy-driven one, and a metallurgist is very, very important to be stationed in the manufacturing plant to control the chemical composition of the reinforcement. The inspection of the steel bar product can be divided in two stages: mill inspection and finished product or final inspection. Tests have to be made during the finishing operation on the rolled bars. Pickling test, eddy current test, ultrasonic and magnaflux test, and etch test. So manufacturer record and delivery documentation. So you have to insist this as per 1786 and other relevant codes. The manufacturer should give some basic information to the user along with the supply. So the manufacturer shall establish and maintain the records required and shall identify the steel reinforcing bars and their delivery documentation accordingly. Each delivery, the manufacturer shall supply the following information. It is mandatory. You can demand for all this information from any supplier. It is not just bring and dump on the site and go. Manufacturer's name and place of production, nominal diameter and grade, the EAT cast number and cast analysis, including all specified elements and elements used for the calculation of the carbon equivalent value, the results of the tensile test and rebend test, the mass per meter, the weight of the reinforcement bar, the results of surface geometry measurement or beam test, the manufacturing process route, which method, in the beginning we were talking about, there are two routes of manufacturing, which method they have followed. For ribbed steel reinforcing bar, the rolled on identification mark on the bar, they have to print the IS number and the brand mark that should be there, and result of a fatigue test if required by the purchaser. This is optional. All other information should be supplied along with your delivery list, along with the bill, in other words. So checklist for initial scrutiny of drawings and schedules. This is also very, very important. We may talk about so many things. The manufacturing method should be like that, everything. But finally, before implementing the reinforcement, before using the reinforcement, if you take care of all these issues, then automatically we can avoid a lot of unwanted items, and we can focus on the quality. Can the reinforcement as detailed be fixed? Does the detailing permit sensible location or construction joints? Sometimes it is also very important. The site engineer and project engineer, especially the civil engineer responsible for fabrication of the steel at site, should also have knowledge of all these things and detailing exposure. Because you cannot, most of the times, you cannot blindly assume that drawing coming from a consultant can be directly implemented. You should glance the drawing and identify whether it is okay or not. Sometimes in a hurry, in a demand, because there is a lot of pressure at site for the drawings, some junior might have released the drawing without the scrutiny of the higher ups. So you cannot simply implement the drawing as it comes from the consultant. I'm not blaming the consulting offices, but it is also very important. As civil engineer, we should glance through, and if anything which is abnormally visible in the drawing should be brought to the notice of the consultant and get it rectified before using. Because once you cast the reinforcement concrete, then it is very difficult to undo the process. Many times, even though we identify small mistakes after concreting, we ignore. We don't undo the process. We don't demolish and redo the work. So with this in mind, I think these tips are very, very important for all of the civil engineers. Is the reinforcement congested? So the congestion of reinforcement is another one reason for behavior of the element. Would alternative detailing provide greater flexibility or ease of fixing? These questions can be asked by the designer himself or herself while releasing the drawing. Whether we address all these issues while releasing the reinforcement drawing for the execution. Is there a scope for prefabrication? What is the best sequence? Is the reinforcement detailed to provide sufficient rigidity and stability cages during fixing? Or set up bars, bracing bars, chairs, spacers, etc. or required? Do schedule agree with the drawings? Does reinforcement in one member clash with that in the adjacent member, or scheduled bending dimensions compatible with member dimensions, like this? So delivery checklist, again, ensure adequate offloading space, check weights given on delivery ticket, ensure correct handling during the unloading, check reinforcement is of correct type, bundles are correctly labeled, check reinforcement is of correct grade. This is very, very important. Normally, they supply the steel, use it. You might have ordered for a FU 500 or a 500D or 500S. Whether you're getting the same steel to the site. Before issuing to the site fabrication, you should check all this. Check the bar sizes. This is also very, very important. Many a times, the small variation in the bar diameters, if it is not properly checked, instead of using 16 mm, you might have used 12 mm or 20 mm or 16 mm. This kind of mistakes also happens when it is a bigger site. So the project engineer should be very careful about all these thing. And you should also look at the scale and fitting of the bars, whether it is good textured bars. Similarly, you have a storage checklist. I will run through you should store the steel as per the guidelines of the codal provisions. Bending checklist, I'll run through. Pre-concreting checklist, you have a lot of checkpoints. We will take up some questions and then we'll we'll come back if necessary. So you can go through, easy to understand. And site actions influences cost. Definitely, if you properly manage the steel selection and usage, all the methods, you can also save a lot of material. And finally, cost is also very, very important for all the projects. And you can minimize the cost of the project by taking care of proper quality measures, not only for reinforcement, for all the materials that we use in the site. Many times these days we see a lot of scope for retrofitting and rehabilitation. It is becoming a huge industry now. Just after 5 years or 6 years, buildings are subjected to repairs and retrofittings. So that is because we don't proper adequate quality measures during the selection of the raw materials and selection of the construction materials before using. So if you focus more here, then the maintenance issues will be very minimal. And you have steel reinforcement checklists also available. It is available in most of the consultants' office. You can have a detailed checklist. I have taken this from I think from a L&T project.
ಮತ್ತೆ
Right?
ಕಾರಲ್ಲೆಲ್ಲ ಮಾಡ್ಬಿಡ್ತೀಯ ಏನು?
So reinforcement was category of reinforcements. All these things are given with a due acknowledgement to all these people who have taken their references only for the concrete. So ICI and some manufacturers, we have come out with some guidelines for student education also. Some of the charts, these are the various IS codes available. About 39 to 40 IS sectional divisions are there. You can work, choose to work in any of these and assist Bureau of Indian Standards also for revising the codal provisions. The most important reinforcement steel related codes also I have listed here. You can go through these codes to understand and effectively use the reinforcement. One needs, as a civil engineer, it is mandatory that they should go through all these code books, which is very, very essential. You have a sound knowledge of a material or a product, then you have authority in deciding and using the material. So, as civil engineers, for a longer run, to be a popular and efficient consultant, efficient engineer in the field, I think we need to go through all these codes and conversant with all the codal provisions and revisions as and when BAS releases. So I've used some of the references. You can also go through these references. The ICJ journal has carried an article of S.A. Reddy and others, which gives talks about the certification validation aspects of I think some of that I've taken in this presentation. And you can also look at the World Steel Organization, IBF, and there are some newsletters released from various stakeholders. You can also visit the manufacturers' websites to know and understand the quality systems that they are adopting for manufacturing. And I'm very happy to mention here, I'm also involved in preparing this reference manual for field engineers on building construction. This was released by the Task Force for Quality Assurance in Public Constructions, Government of Karnataka. This book is freely available to download at the KPWD Karnataka Public Works Department website. You can click on this or you can directly click on this link. You can download a very good volume of reference manual material. You can go through that. It not only talks about the reinforcement aspects, but it starting from the reading the architectural drawings to the execution, all aspects involved in the construction industry are briefly dealt with in this handbook. And this handbook is prepared under the guidance of late Dr. C.S. Vishwanatha as the chairman of task force. When he was the task force chairman, I was fortunate enough to involved in preparing this manual as the editor in chief under the guidance of engineer L. Ravindranath as a member secretary. The who is who in construction industry, the top consultants are all involved in preparing the document. This document, it is a very good reference for all of you to go through. I can download this very easily. So thank you very much. I think I've completed. Uh, we have taken 10 minutes extra. I have not spent a lot of time in each of the aspects. I have not got into the technical aspects of each aspects. My only objective of this presentation is to sensitize all of you how important quality when we talk about the construction materials, especially reinforcement steel. In the days to come, it is very, very essential to identify the manufacturing process, selection of the manufacturer and supplier, and then using the reinforcement effectively for a durable structure. Thank you very much. You can write to me under this mail ID. If you have any queries, I'll be able to assist you. Immediately, I may not reply, but definitely I will come back to you and assist you directly, or I will connect to some of the experts from the Association of Consulting Civil Engineers. You can also visit the websites given my college website also, and SCC website also. You can get into the different working groups we have prepared. We have formed working groups under ACCE for addressing the various issues of construction industry, and they will address directly to your queries. Thank you very much. Over to Rahul Patil. Dr. Rahul Patil, thank you very much. If you have any questions, maybe you can take one or two questions and we can conclude.
Thank you very much, sir, Ashwath sir. It was a wonderful session. So I would like to ask the participants if you have any doubts, you can one by one you can unmute and you can ask the questions for another 10 minutes. Yes, any of you. Yes, Abdul.
Good morning, sir.
Good morning.
Yeah, sir, I was a student in 1990-94 group batch, Ashwath sir.
Oh, thank you. How are you doing?
Fine, sir. Remember me, sir? Abdul Kalim.
Yeah, Abdul. Tell me.
Sir, this bending, rebending, this subject, I've been there in the industry from 25 years. I've done masters in construction technology also.
Okay.
But I'm seeing this rebending, most of the people doing at site manually. Is it possible to generate some type of hydraulic machine where we can address this subject, sir?
Yeah, I don't know, but there are a lot of confusion in rebend test. Even the
because
suppliers
one of my
and manufacturers they don't advocate good procedure for bend and rebend test. I've seen some of the manufacturers go to the site with some bars, bend
yes,
as many times as they want, and show this is a very good material. It can bend to any shape that you want. This is not the
correct, sir. Exactly.
They cannot
exactly. One of my friend is who is also a mechanical engineer from BIT in the same group.
Okay.
Is having a Torkari industry in Chennai.
Okay.
And by name Pro Steel Industries. I think heard about Pro Steel Industries.
Yeah.
So there, when we visited the site for doing this 3D weld mesh industry, which we did one project in Boisar near Bombay.
Okay.
Most of the people they do rebend test on Torkari also in a fashion where it is very old age systems, which they don't apply for going from proper technical aspect on that.
So as of now, we should promote only whatever is suggested by the Bureau of Indian Standard Method. If any other method is there and any of our mechanical friends joining collaborative work can be approved, sent to...
I am thinking to something work with the mechanical people to come out with a solution for rebending systems.
A lot of things are happening in the construction industry. It is very dynamic. You can do a collaborative research, interdisciplinary research, and the product can be submitted to the Bureau of Indian Standards for vetting. And if they vet, they can implement in their revision of the code. As
Okay.
of now, we should follow whatever is prescribed
Yes,
in the
sir.
Bureau of Indian Standards.
And most of the people who don't follow this 135-degree at all, sir, just get the bar.
That's why I stressed that aspect. You need to follow the system very clear. Thank you. It is a good question.
Sir,
Yes, sir.
is there any norms for testing the chemical tests? Many times the contractors, developers, they will be reluctant to do the chemical test. Is there any binding for them for so many tons or for batch you have to do chemical test like that?
Sir, actually, for every batch, they should do this chemical analysis. In fact, every batch of manufacturing of billets, see, some manufacturers, it is a continuous rolling billets and then directly into the rolling. Some manufacturers, they make the billets and then they do the rolling process. So at the time of manufacturing the billets, they should do this chemical analysis in-house, and you can demand for the chemical analysis test at the from the factory itself, or you can ask any third-party accredited laboratory to get it tested randomly for your supply. So
No, my
this is a
question
very
is,
simple test. It is very simple. Many people think it is a very complex experiment. It's a very simple test. They have a system of procedure to make the sample, and automatically you get about 27 chemical components. And I've shown you, this test sample. It is a very simple test. Every manufacturer should have, and if they don't have, you can insist. They can buy one and do the test.
no, sir, manufacturers generally they will give that MTC, but the
Yeah.
problem with the third party test, is there any rules and regulations to get it compulsorily get it done like that? Third party test.
Sir, it is mandatory for all the batches. So you can ask whenever, if you are getting a huge quantity of reinforcement cell, you can ask if they change the batch of raw materials, then for every batch you can insist this test. And randomly you can take samples and get it done by the third party laboratories. So this is the test. A simple billet is there, sample billet, you get the complete analysis. Yes, sir. Any other question?
Sir, one more thing
Yes, sir.
regarding this fiber instead of steel, which is majorly used, like as you said, 56% of steel is used in the construction industry. So introducing fibers into it, PVC solid bars for minor structures.
Okay.
Any input on that, sir?
Sir, fiber reinforced concrete is developing very fast. In fact, some of the consultants, Mr. Basuraj, Chetana Consultants, Basuraj,
I know, sir.
the dream is to not to use reinforcement steel at all in concreting.
That's what I'm
So
looking
to
for.
reduce the minimum stage and use only fiber reinforced concrete. As of now, we are not in that stage, but adding the fibers will definitely increase the tensile strength properties.
I'm in touch with Basuraj, sir.
As a replacement of reinforcement steel, we are not at that stage as of now.
Okay, sir.
Yeah. If you have any other questions, please go ahead. We'll be able
Sir,
to
I needed to ask.
Yeah. Who is this? Please say your name and.
Sir, I'm Arihant, sir. I'm a civil engineering student right now, BE in Mysuru.
Okay.
Sir, nearby my house, I saw construction where the frame of the structure was being replaced completely with steel members. They had taken I sections and they had, like a huge ones, and they had welded it together.
Yeah.
Do you think those will be a good replacement for the, like reinforced concrete in the future, or are there still any downsides to using pure steel as a frame?
No, the use of structural steel is increasing because we are not used to steel structures. In other countries, steel structures are very popular. In our country, we are used to concrete structures, but now consultants are understanding the property of steel and efficiency of structural steel, and people are using more and more structural steel alternative to reinforcement frames. So structural steel is a fast construction and sustainable construction, and definitely a good alternative to reinforced concrete structures. Many these the trend is towards fabrication of reinforced. I'm sorry, fabrication of structures using
Composite systems.
yeah, composite systems. Yes.
Audible, sir, myself.
Any other questions?
Hello.
Am I audible, sir?
Yeah. Please go ahead.
Sir, myself, Pradhan. Sir, I want to just one little bit query. What is the sampling rate for the on the tensile test, bend test, all this site actually for the sampling rate? Suppose I'm getting 50 ton steel, yeah, 100 ton steel, yeah, or 200 ton steel at a lot. So, is there any specific guidelines for the sampling rate?
Sampling, I think it is given in IS 1786. I exactly don't remember, but I remember for every batch there should be a test. A batch of manufactured steel. If you're getting from the same source, for every batch of manufactured.
For every 30 tons, we do one sampling, sir.
Okay, maybe.
That's why I'm asking actually. The batch that is related to batch, yeah, any ton specified there. That is not.
Please check the code. You will get the exact sampling rate. I don't remember right.
Okay.
Yeah.
So this is Chandrasekhar here.
Yes, sir. Please.
I'm a civil engineer and do consulting also, and I have my own construction company. So I got two questions. Sir, all these webinars, do we get any recordings of the things, sir? Is it been posted in the?
Most of the webinars are recorded and they will be placed in their respective websites. ACC, we have conducted almost more than 30 webinars during this COVID-19 season with various industries partnership. Some with Ramco Cement, some with SK Steel, some with Ultratech, even Indian Concrete Institute, where I was the vice president for the previous term, doing a lot of webinars in through Indian Concrete Institute, Bangalore Center, and All India headquarters. So if you visit the ICI website, you get a lot of webinar recordings in the ICI Bangalore Center website, and ACC website, and Ramco Cement's website. And I request the organizers of this program also to upload the recording in their website link. That will be useful for all the members.
And my second question is that, sir, I keep on following all these webinars. Sometimes I miss the webinars date and other things like.
Okay.
Like, how do I know? Like, is there anything where I should register myself so that I get regular updates of the webinars happening, sir?
You're a civil engineer?
I'm a civil engineer, sir. I've done my diploma in civil engineering.
You can become member of a student chapter of either Indian Concrete Institute or Association of Consulting Civil Engineers, or both.
Okay.
There the organizations post the webinars details in that.
Okay, sir. Yeah, thank you, sir. Thank you very much.
Thank you. Wish you all the best.
Thank you, sir.
Yes, any other questions? Last 2 minutes.
Okay, if there are no questions, maybe you can conclude. I can see Dr. Manjunath. Thank you, sir, for the opportunity. I've tried my best to compile the information after Rahul Patil asked me. Just clubbed some information just to sensitize. The objective is to sensitize. It is not very difficult to teach all the aspects of reinforcement in 1.5 hours lecture. But definitely, if anybody requires the participants, I can still see about 250 members. They can always come back to any of our professional bodies, and they can also write to me. I will be able to assist them in educating on various aspects.
Hello.
Yeah.
So good morning. Myself, Gyan Singh. I'm a student of civil engineering. My question for the welding: what happens if rebar member welding at site, and what precaution we can take?
I can simply say welding is not very effective in the sense the trained people for welding the reinforcement bars are not available. in most of the sites. Either they are used to lap earlier. So welding will reduce the lapping definitely and it save material, but welding techniques should be used as per the IS code procedures. But rather than welding, now the couplers are available. I've shown some slides on the couplers. It's easy to do the coupler, use the couplers for instead of welding. This is more effective now
Yeah.
and
So
faster.
this is for the lapping and splices. But
Yeah,
my question for the replacement of starter. If we want to replace the starter and use a tie member and weld with a stirrups our main reinforcement, then what happening at vertical reinforcement and what is the pros and con uh, welding effect?
okay, for the starters, I'm not very clear what exactly your requirement. So please mail your question to my email address. I will consult some other experts and I will come back.
Okay, thank you all. And the session has been recorded in YouTube channel also. Okay, it is JIT Civil Department. It was running live also. So whoever are interested, they can just go through that particular YouTube channel. And even I asked Ashwath sir to share this particular PPT with me so that I can share to the all email IDs also. If
Okay, I'll do that.
Ashwath sir allows me. Okay, sir. And we have had an extremely useful day, sir. So our principal want to speak something. Okay. So Manjunath sir, you can speak, sir.
Yes, sir. Good afternoon, sir. Dr. Ashwath, sir.
Yeah,
I'm
sir.
very happy that you accepted our invitation and give an webinar on quality of reinforcement. It was very useful at this time of juncture because of the COVID holidays. We need to engage the students as well as the faculty members somehow, and it is the right time to conduct all these things. Once again, I thank you, Dr. Ashwath, sir, Principal of Bangalore Institute of Technology, and also Dr. L.R. Manjunath. Yesterday, he has conducted the webinar on the same topic. I thank once again on behalf of Jain Institute of Technology for both the resource person accepting our invitation and giving a webinar on these topics, sir. Thank you very much, sir.
Thank you,
Please
sir.
do
Thank
visit.
you very much. I thank all the participants also for
Yes, sir. I also thank the participants, nearly 300 participants. I can see the maximum number of participants in this webinar. Because it is the resource persons, this one has made the webinar successful. I also thank Dr. Rahul Patil and his team members for conducting this webinar, and they took nearly 10 to 15 days time for organizing all these things. Thank you very much, sir. Ashwath, sir, once again.
Thank you, Manjunath sir, and thank you, Rahul, for taking the initiative. And please continue this. It will be useful for the profession as well as for the student community at this point of time. Thank you very much.
Yes, sir.
Yes, sir.
Once
You,
this
sir.
pandemic situation will be withdrawn, sir, later we hope so that you will visit once our college so that we will have one session offline also, sir, in
Yes,
future.
sir, definitely.
Okay, we will be in touch with you.
Yes.
Okay, sir. Thank you very much, sir. You have handled it very nicely. All the questions, sessions was very wonderful. Interaction with the students, all the faculties. So I would like to thank all the participants who have joined. Okay, and whatever the feedback forms you will send, it will be taken as positively, and we will send you the details also. And we will ask any, if you have any technical questions, I would like to ask our Ashwath sir to solve the issues or problems, whatever it might be. And the certificates also will be issued to you people. Daily 100 certificates will be issued. So need not worry. Within 2 to 3 days, the certificates also you will be get through your email IDs.
You take the feedback.
So once again, I would like.
You take the feedback,
Yeah.
then issue the certificates so that you get some.
Yes, sir. We have made.
And it is also
Yes,
required
sir.
for the various accreditation bodies. Also, feedback is very essential.
Yes, sir. Even in future, we are going for the NBSR accreditation, so it will be helpful for us also. So all the documents we are collecting it, sir. So thank you, sir. Thank you once again. Thanks all the participants. Thanks Manjunath sir for giving me the opportunity. I would like to thank the coordinators Rohit Kumar, Raghu GM, and Harish sir. and other faculties who have joined with us for this wonderful session, who have made this successful. Thank you, sir. Thank you once again. Thank you, Ashwath, sir.
Thank you. Thank you very much.
Thank you, sir.
Thank you, sir. Thank you.